Gustav Robert Kirchhoff was a German physicist born on 12th March 1824 in Prussia. He is still known for his contribution towards understanding of the electrical circuits, spectroscopy, and the emission of the blackbody radiation. He wrote the circuit laws in year 1845, which consist of two laws, Kirchhoff's current law and Kirchhoff's voltage law. Both the laws allow us to understand the concept of closed electrical circuits and the flow of current and voltage. And a fun fact for you guys. Did you know that Kirchhoff was the one who coined the term blackbody radiation?
True story.
So coming back to KCL. His current law states that for a parallel path, the total current entering a circuit's junction is exactly equal to the total current leaving the same junction. So as the formula depicts, summation of the current in is equal to the summation of current out. In other words, the algebraic sum of all currents entering and exiting a node must equal to 0. A simple example could be, let's say IR3 and IR2 are current entering through node 3. So the current leaving is simply IR2 plus IR3. Isn't that elegant and simple? So this idea by Kirchhoff is commonly known as the conservation of charge, as the current is conserved around the junction with no loss of current. Let me explain the concept and importance of KCL through an analogy. As I mentioned earlier in the video, KCL states that current entering a node or junction is equal to the current leaving. So let's say that the flow of water is current and the stone is acting as a node. The water flowing inside is splitting two ways, and we can see that the water entering and the summation of the two branches of water are equal, which states that there is no loss of water or no loss in current, which is a clear evidence of conservation of charge. KCL is a great analytical tool. We could easily find current through one branch using KCL. So this is a simple circuit where we are about to find I2, which is the current passing through resistor 2. The most important thing to remember is the sign convention. If the current is passing into the node, then it's positive, and if the current is passing out of the node, then it's negative. So for that reason, we have I1 minus I2 minus I3 equals to 0, and where we found out I2 equals to 1. And here we have a small homework problem. Try to solve that using KCL.